Welcome back. This is section 3, and in this section there are 6 questions. All questions are numerical value type questions. Here there is no negative marking. This is an advantage, and full marks, that is 4 if only correct numerical value is entered. Let's start our video right after this short break. And if you are first time on my channel, then please subscribe and hit the bell icon button to get the video first. Let m be the minimum possible values of this, where y1, y2 are real numbers. y1 plus y2 plus y3 is given over here. And the maximum possible value of this. And for this one, x1, x2, x3, positive real number, this sum is 9. Then the value of this you have to find. So from this, as their maximum and minimum they are asking, so this shows, and these are the, as the exponential term, these are the positive. So by default you can think about this one, that this problem is from AMGM. As you all know that here, let me write AM is greater or equal to GM. This is a favorite inequality of JEE, you know, so they won't forget to give any time this problem. So from this segment, one problem should be there in paper every year. So let's see. So AM is greater than GM, and it's very easy. And now then you apply in these positive numbers, because this inequality can be applied only for positive numbers. So 3 to the power y1, 3 to the power y2, 3 to the power y3, these all are positive. So apply this 3 to the power y2 plus 3 to the power y3 upon, there are 3 terms, so greater or equal to cube root of, here just multiply this 3 to the power y1 into 3 to the power y2 into 3 to the power y2, y3. Okay. So what we call here, transpose this 3 to the power y1 plus 3 to the power y2 3 to the power y1 plus 3 to the power y2 plus 3 to the power y3 is greater or equal to, 3 into y1 plus y2, what we recall here, 3 to the power you have to write here. So let me write like this way, 3 to the power y1 plus y2 plus y3 upon 3. So this you have to say upon 3. And in this way we can recall, as y1 plus y2 plus y3 is 9. So when you put here 9, 3 is 9. So that it will be 3. And here that is 3 cube, you can recall. So finally that is 3 to the power y1 plus 3 to the power y2. That is 3 to the power y2 plus 3 to the power y3. And now what do you have to check about here, as they are asking about log. So when you take log, then these numbers which are in power come down, and in this way we get this one. So the minimum value of, so minimum value of log of 3 to the power y1 plus 3 to the power y2 plus 3 to the power y3 to the base 3 is equal to, that is log of 3 to the power, you say 4 to the base 3 we are taking, so that what we call 4. So the minimum value is 4 over here. Okay. So as this is a minimum value, now you have to find the maximum value. For maximum value of log of this, what do you have to say? Let's start to solve this one. Similarly, you can go here also, log of x1 plus log of x2 plus log of x3, and x1, x2, x3 are positive numbers, of course. So what we recall over here, that is for log x1, x2, x3, this one. So let me write maximum value of log of x1 to the base 3 plus log of x2 to the base 3 plus log of x3 to the base 3 is equal to, one can write over here that log of x1, x2, x3, this is the formula for log, and base 3. For this, what we write, as you know, this is x1, x2, x3. So this is, that is here x1, x2, x3, these all are positive quantity. This you can evaluate by using AMGM over here, as here you can see x1 plus x2 plus x3 upon 3 is greater or equal to x1, x2, x3, that is to the power 1 by 3. Here you substitute 9, so here you substitute 9, so 3, 3, 9, and here 3 to the power 1 by 3, this one. So what we recall over here, this is nothing, this we can write now, log of x1, x2, x3, we say on cubing both sides, what do we get? 3 cube, so to the base 3. So from here you can get the value of, you can write over here also, x1, x2, x3, that is 3, okay, 3 to the power 3 is 3 to the power 3. How? As you substitute over 9 here, this 9 you can put over 9 here, so 3, 3, 9 cubing, you get 3 cube, so log 3 cube to the base 3, that is 3. In this way you can find maximum value of this as 3. Now what do you have to find? You have to find this one, log of this. So let me write log of, finally what do you have to find? Log of m to the power, log m to the power 3 to the base 2 plus log of capital M to the power 2 to the base 3. Whereas capital M is the maximum possible value of this. This is capital M, and small m, this one, where is small m? Small m is the minimum possible value of this. So you can say this is small m. So small m is 4, and capital M, you say this is, you can say here, this is 3. So capital M equal to 3. Now substitute these values. So after substituting here, what we recall, log this one 4 cube to the base 2 plus log of this one 3 square to the base 3 to the base 3, yes. And after solving this, what we recall over here, 4 cube can be written as this one. You can make it as like this is 2. This is base 2, what do you say here? And 2 to the power, what do you write? 2 to the power 2 for 4 you can write here. And hence we say that it will be here, that is 6, and here you can shuffle this as log 3, 3 to the power 2, and this will become as 3 base 3, 2 will come over here, so that is 2. Okay, as you can say 2, 3, 6, and here finally the answer is 6 plus 2, that is 8, and 8 is your final answer. Okay, so let's go for problem number 14. Let A1, A2, A3 be so on sequence be a positive integers and arithmetic progressions. Common difference 2, and B1, B2, B3 are in GP with common ratio 2, and A1, B1 equal to C, and here that is sum of AP is given here, and this is sum of GP. So apply the sum of AP formula, that is what is the sum of AP? You say n by 2, so 2 retaliated directly. Let me write over here. So that is n left. Let me take another color that you say here. It's okay. So n by 2, you write n because 2 related. So directly I am writing over here. And 2a, 2 into first term. First term is that you say c. Better just write 2 into a1. For a1 we will write later on c plus 2a plus n minus 1 into d. N minus 1 into d is the common difference. Common difference is 2 here. So you write 2, and here better just write 2 into n by 2 just for sake of convenience. Let me write. And here this is sum of GP. So A1 into R to the power A1, that is B1 into R, that is common ratio. Common ratio is here still 2. Common ratio is also 2. CR, common ratio. That is means 2 to the power. How many number of terms? N. So n minus 1 into upon 2 minus 1. It's okay, fine. So B1 and A1, let's say that is a C given in the question. This 2 and 2 related, and here what we find here, that is 2C plus n minus 1 into common difference, that is 2 once again, and here once again you have to write C, and that is 2 to the power n minus 1, and that is 2 minus 1, of course 1. So finally what C you will get, C we left with C equal to 2n square minus 2n, okay, and upon 2 power n, correct, and minus, that is what we say, C with this, then we say minus 2n and minus 1, hence we find on transposing you get the value of C here. Now C, that is, since here it is given that number of all possible values of C for which the equality this holds for positive integer. So C belongs to some natural number, that what we say, and here in this way we say 2n square, right, cross multiply 2n square minus 2n square minus 2n. So this should be greater or equal to 2 to the power n minus 2n and minus 1. Now you have to see here 2n square plus 1, what we recall this 2 and 2 related, and here that is greater or equal to 2 to the power n. So in this situation what we say here, that you just see over here, means this you can say, so as you know C is positive over here, positive integers, these all are positive integers, so b1 b2 b3 a1, these all are C. So that this implies, you can say here, that is for n is less or equal to 6, n is less or equal to 6 also, because if you say here, that is 6 will be, the number will be less or equal to 6, it's very clear. And here also C is positive, and here this implies n should be greater than 2, and therefore so the possible values of n are, so the possible values of n are, so the possible values, let me write here, possible values of n are, what is the possible values are n are, that is 3, 4, 5, 6. Now check, when n is equal to 4, so if you put n equal to 4, that is here you say 16, and then what the value of C is over here, so you just evaluate here, 16 minus and this one's 2n square, that what we call here 16 to 32 minus this one 8, and that is 24. So this implies C equal to that is 24 by 7. 24 by 7. Is this possible, as C belongs to a natural number? So this is not possible. Not possible. Okay. So what we say here, now test for n equal to 5, if you test n equal to 5, then this implies c equal to, now substitute 5 over here, 5 square 25 to 50 minus 10, that is 40. And here when you put here 5 or 2 power 5, 32, that is minus 2 to 4 and minus 1, 5 and 5 to 10 minus 1, 11. So that we say 21. Okay, 21. So this is also not possible, right? Ditto. And for n equal to 6, let's test. What do you say here? So what the value of c will be? N equal to 6 when you submit 6 over here. So that will be 60 by 51. So 60 by 51. And here this is also not possible. So what we conclude over here? So there exists only one value of c. So we say here, you can write over here. So there exists only one value of c. That was left with 3, which we haven't tested here. So let me test over here, n equal to 3. That's we say c was, you can say 3 submit here, 2, 9, 3, that is 12 value. So c is 12, which is natural number. The only result is left here. So there exists only one value of c. Only so c equal to n equal to 3. This is the solution. So what is they are asking here, holds for some positive integer n is the number of all possible value of c. So the answer will be only 1. So only one values of c will be there. So the answer is 1 in this. This is our final answer. Let's see about this one. F such as 0 to 2 to r be the function defined as fx equal to, this is some trigonometric functions is given over here. So better just you can go like this way. You can assume this as angle because everywhere there is a pi x here, you can say. So you see over here that we have to find the values alpha beta 0 to 2 such that x belongs to 0 to 2, fx should be positive, right? So must simplify this as fx. So if you simplify over here as fx, so you can consider this pi x as theta, or directly you can evaluate it. Let me see fx equal to, what we say, let me write first 3 minus sine, that is 2 pi x. This is first bracket. Another bracket you can say here sine of, that is you can say pi x, sine pi x. And here when you open this, sine a minus b sine a cos b minus cos a sine b. So that is 1 by root 2 pi by 4 value of sine and cos, that is minus cos. So we say cos of pi x, and here that is upon root 2, you can say over here. And considering this as a theta, then this will be 3 theta, so means 3 times of pi x. So we write over here means minus of sine, that is 3 pi x. And then after means this is also root 2, and that is plus upon root 2, you can write over here, and plus cos theta, cos 3 pi x, you say, and here also root 2, that is pi by 4 value. Now open this all, what we say here, take out 1 by root 2 better common, and then what we recall here, so 3 minus sine of 2 pi x, you can say over here, and then after that is sine pi x minus cos pi x. Okay, and here what we say minus, if you open this sine 3 theta and cos theta formula, so that is 3 sine pi x. Okay, and minus you write 3 cos pi x. Okay, so if you take here common over here, then because 4 cos cube theta minus 3, so this will become negative. So this is negative, means positive. So negative when you take common, that it will become negative. And here that is minus, you write here minus 4 sine cube pi x, and we say plus, because minus sign is common over there. So plus 4 cos cube x. 4 cos cube pi x, and hence we say this is the entire result of this one as 1 by root 2. Now let's solve somehow. So finally what we get here, you can see this one is sine pi x is there, and here cos pi x is there, and here 3 sine this one 2 theta is there. So when you solve it here, then you can take out common over here, sine cube x and pi x. So sine cube x is pi x is already negative, and cos pi x is positive. When you take minus 4 common over here, then you will find sine pi x minus 4 cos pi x, and here sine pi x minus 4, cos pi x is already common over here. So finally, when you take throughout here from this and this and this will be get 2 brackets, and here we find that is when you take common 1 by root 2 as like this. Let me take a common over here. So that will be said to be sine pi x minus cos pi x. Okay, and hence we say that is, let me write down direct 3 from here minus sine 2 pi x, sine 2 pi x. Okay, and from here that is entire bracket is common, and that is left with 1, and when you take here common over here, then you will get here plus 1, and then minus what we say, minus directly if you check over here, then if you take it entire common, that is 1, and 1 cancel, and sine 2 theta by 2, and this 2 cancel out, that is 2 sine 2 theta. So that is, we say here 1 minus 2 sine 2 that is pi x, right? So this is the final result, and hence we say here this is so finally what we conclude over here, that is for fx to be positive, what we say here, if you see fx to be positive, therefore fx to be positive means greater or equal to 0. You can see over here, you can see fx is greater or equal to 0. Then here you can just plot the graph, means here this should be positive, so the sine part should be positive over here. So from where it is positive, let's see. So you have to draw the graph of sine and cos. Let me draw the graph of sine and cos over here on the same graph paper. So let's see, this is x-axis, and this is what we call y-axis over here. Okay, here this is y-axis, let's say, and this is y-axis, this is x-axis, and let me draw the graph of, first of all, sine pi x. So sine pi x is here, you can see where we can go ahead for sine x at least, and then we will go for pi x to just analyze this all. So as alpha beta also lies between 0 to 2. So 0 to 2 means nearly up to 2 pi. Within a cycle you have to plot the graph. So if we draw for, this is the graph of sine pi x, let me draw like this way, and here this is sine pi x. Actually it completes the function for this one 2 pi, so this will be 2 and this will be 1, and this graph will be sine pi x. When you put x equal to 2, so that will be sine 2 pi, so it behaves as sine 2 pi, and here this point is somewhere means here that is 3 pi by 2 where it is, and means that will be 3 by 2. You can plot over here, and this is 1, and let's say this is somehow this one 1 by 2. Let's see, and draw the graph of cos x. Now draw the graph of cos pi x. So what do you see here? Cos pi x is just like this way. The graph is here. They both meet at pi by 4, means that this will be 1 by 4, and here where they are meeting, and they will cross up over here at just 1, which is that a pi point, and at 3 pi by 2, this is 0, and this is the graph of cos, and here this graph is cos pi x, you can say, as it is passing through 3 by 2, and here the point where they are passing, let me draw these all lines somehow. So let this mark these points. So the point where we mark over here, this point. Let me draw like this way. This point we can mark, and here this point we can mark over here. And so we will mark these points where they are, these curves are meeting. So we will go for to uplift over here. So this point is somewhere here where sine and cos meets. So that is pi by 4 points. So it will be 1 by 4 as both the graphs are pi x and pi x argument. So this is 1 by 4 point over here. And here you see, let me write with this color, white color. So this point is 1 by 4, and this point, this point is 5 by 4, because that will be 5 pi by 4. So this is 5 by 4, right? So this point is 5 by 4, you can say. And here this is 1, of course, this point is 1, and it's okay. And this point is 3 by 2, which is previously not out. And okay, and this point is 2, fine. Now this is the graph where cos pi x is going on. So we have to consider the points where we find that sine graph is this one. Sine will be positive to cos x, because this term will be throughout positive, right? So as you can see over here, this is throughout positive, 3 plus 1, 4, and minus sine 2 pi x minus 2 minus 3 sine 2 pi x. Okay, so here you see, means we have to just only consider this part of the bracket where the sine pi x is greater than cos x. So we have to, let me draw over here, that is with some blue shade. So that is the region where the sine pi x is greater than. So we have to go this part, this portion. At these all portions, what we find, sine pi x is greater than cos pi x. So what we conclude over here, that the fx is positive, where it is going to be positive, wherever we find sine pi x is greater or equal to, you can say here, means greater or equal to cos pi x graph. So these blue dot shade parts are the result of our solution. So what we have to find, alpha beta, that will be which lie between 0 to 2. There's so we say alpha, this interval alpha comma beta, what we show over here. So this is equivalent to the interval 1 by 4 to 5 by 4, if you see over here. So that will be 1 by 4. This point is 1 by 4 here, and this point is 5 by 4. So this implies that we find beta minus alpha, that is 5 by 4 and minus 1 by 4, and hence the answer will be 1, and that's your final solution. So answer is what we say, beta minus alpha you have to find, that is answer is 1, and that's your answer. Okay, so in this way we can handle this question, and now go ahead for next question. Question number 16. In a triangle PQR, vector A is equal to QR, vector B is equal to RP, vector C equal to PQ, and if mod A equal to 3, mod B equal to 4, and vector A dot C minus B upon vector C dot A minus B is equal to this given. You have to find the vector A cross B whole square. Okay, so here there is a triangle. You just draw a triangle over here, any triangle. Let's say this is, and another triangle here, and let's say another triangle that is here. So you consider this point as, let this point be P, Q and R. So here it is given that QR vector is vector A, and RP vector, that is vector B, and C, that is PQ vector. So from here it's very clear that we say it is given A plus B plus C. These vectors are 0. These vectors are 0 here it is given due to this triangle. So if you see here, then what we recall, if you make a dot product with A vector, then you will get A dot A plus A dot B, okay, and then plus A dot C, that is 0. But you know, A dot C here is equal to, as A dot A mod A square, here you will get 9, and as you know, here that will be minus 9. Okay, and then after we can write minus A dot B vector. And so this materials we find. So let's say this as equation number 1, this as equation number 2, you can say. And what we say here, if we make with dot product B, so A dot B and plus B dot B, and then after here we find C dot B. As you know, it follows commutative law, so you can put anywhere like this. So C dot B, what we recall over here, that is minus 16, because mod B whole square, that is this value is 16. So transposing, we get minus 16 minus A dot B. Okay. So now the given result, that what we say here, that is A dot C, A dot C here, multiply with this minus A dot B, and what we say is C dot A, you can say here, from here we are writing, this is given, minus C dot B, that is substituting these values here, what we say, this is 3 and 4, from here plug in this value, so 3 plus 4, that is 3 by 7. Okay, so this implies that, it means this implies here what we get, cross multiply, so 7 dot, that is A dot B, 7 times of A dot B, and here we get 3, 7, 4, so that is 4 times of A dot C, and plus 3 times of B dot C. Okay, fine. So what we conclude over here, that is, this implies, so 7 times of, so from here we get 7 times of A dot B, minus, we say 4 A dot C. What the value of A dot C here? Minus 9 A dot B. So 4 times, put this value over here in A dot C. So 4, 9, that is 36, minus 36, 7 A dot B, equal to, you can say, here equal to is that. So equal to minus 36 minus 4 times of A dot B. Okay, 4 times of A dot B, multiply with 4. And here that is plus 3B dot C. But for this one, B dot C, what do you write? So 3, you can say A dot B. Here, what do you do over here? B dot C, that is submit this value minus 16 A dot B over here for B dot C. Let us say question number 3, using this 2 and 3 here, what we get here. So finally, for A dot B, minus 48, 16, 3 times 48, and minus, what we say, minus 3 A dot B, minus 3 A dot B. Okay, this much as we find. So finally, what we conclude over here, so that is 7 A dot B, and what the value over here, that is finally what we conclude, that 7 A dot B, and this one 3 A dot B. Okay, and this 4 A dot B. Transpose, here you will get 14 A dot B. Okay, so 14 A dot B is equal to minus 36 and minus 48. Finally, you will get minus 84. Okay, so this is minus 84, and this implies that A dot B you can evaluate over here, that is 14 6 times, so that the value is 6. 14 A dot B, that the value is 6 over here. So finally, what we conclude over here, that is means therefore A cross B also you can find over here, that is the formula that would be say 1 minus cos square theta, that is sin square theta, that we are using over in terms of mod, that is mod A is whole square and mod B whole square, and here minus what we call A dot B bracket whole square. Okay, so whole square. This formula you have to use. So finally, what we conclude that, let me write over here, A cross B, what you have to find over here. So A cross B, you have to put mod whole square. So I am repeating over here, A cross B mod whole square, that is mod A square mod B square. Let me write note down once again, mod A square into mod B square. These values are known, that is mod A square, that is 9, this one is 16, and here that is minus A dot B, and that is whole square. So what we recall over here, that is minus A dot B, that what we call here, that is the value is 6. So you write over here 6 whole square, and hence what we conclude that 916, that is 144, and minus that is 36, and the value will be here after calculating you will get 108. So final answer is 108. That's your final answer. For a polynomial gx with a real coefficient, mg denotes the real distinct roots of gx. Let S be the set of this polynomial with real coefficients, this one. So if you open this now, then what we say here, let's see, let's solve this as here S, that we say here we recall that is x minus, means you say open this x plus 1 whole square, and here what we call x minus 1 whole square, and is another polynomial, that is a naught plus a1x plus a2x square and plus a3x cube. Although here that is the all real number, here nowhere it is written that a3 is not equal to 0, means they are not mentioned that this be a cubic polynomial only. That is the point to be noted. Later on we'll discuss in detail, but first of all you just concentrate on this one, the graph. So let this be any function. So here how many number of roots are there? So let's say this has root minus 1, so means this is f function. For a polynomial f function, the number of roots are here minus 1. Here that is plus 1 and plus 1. So this will be the root. So this will be counted as one root. This will be counted as another root. So what we say here means two another set of roots, and here that it will be some any 3-degree polynomial. You can't say that is because it's not clear. Later on we'll discuss it. Hold it. So if you say here according to the Rolle's theorem, then what we say here, this is minus 1, this is plus 1, and between this minus 1 plus 1 some value is there, that is some value c, where that is 0, means c will be also one of the root. So c will be also one of the root, f means f dash x vanishes. So here if you consider f dash, then it means this provides that is at least one root minus 1, and here that is plus 1 you have to count, and one that will be due to Rolle's theorem. By using Rolle's theorem you can write over here, you can check the Rolle's theorem is verified over here. So according to Rolle's theorem, that is c is the root. So here there are two number of roots are there. So in this situation there are the two number of roots are 3 minus 1, and let's see due to this Rolle's theorem. Later on we'll discuss about another concept, but first of all you go for f double dash. Let's hold for this. So in f double dash x, of course there are 3 roots are here, so here there will be 2 roots will be there. So for this number of roots for f double dash, that is 2, as here there are 3, so here that is 2. So simply you look just this is 2 and 3, so that will be the answer will be 5. It's okay. But the point to be noted, if suppose in the question it was given that a3 is not equal to 0, so that is a cubic polynomial. So it gives some another root over here also, let's say. So that will be considered as here. In this situation, the root may be -1, maybe +1 also. So that will be counted as same. But here, the one more root will be left. So in that situation, the answer may be 6 if a3 is not equal to 0 given. That is the point to be noted of this problem. But here in this situation, a3, here they haven't written anywhere that a3 is not equal to 0. Means this is, you can say, this is whether any 3-degree polynomial means cubic polynomial, or some 2-degree maybe, some 1-degree, some constant maybe. Means you can't say, conclude that this is a 3-degree polynomial. This is some constant function is there given like this way. So in that situation, anyhow, the answer is 5 finally. So let's go ahead for another problem. Question number 18. Let e denote be the base of the natural logarithm, and this limit you have to find. Here it is given the value of the real number a, for which the right hand limit is equal to some non-zero real number. Okay, fine. So in this situation, there is a power function. If you see here, limit x tends to 0 plus this becomes, of course, 1 plus x to the power 1 by x, that is e, and due to this negative sign, that will be e power -1. So this and this term related, and hence we get this is 0 by 0 form. So to solve this question, you just go like this way. Limit x tends to 0. Okay. This question, although you can do one or two different methods, so I will explain here two methods at least. So one, that is a very traditional method that we say use expansion here later on of logarithmic series. Let me explain this 1 minus x. Whenever fx to the power gx, then we use log. So here we can safely write e to the power that we say ln, that means base e. So e power ln of 1 minus x, and to the whole power, that what we call 1 by x, you can write over here. So that it means same thing. And here that is minus e power -1. And as you know, this is x to the power a, you can write over here. And this later on, although this limit to be exist, we have to show here. So this we can say limit x tends to 0. Okay. And then we call e to the power, that what we say log of, that you call log m to the power n. So 1 by x will come downwards. This log of 1 minus x to the base e, you can think over here, and that is x undoubtedly, and that is minus what we say e power -1. Later on you just take out common e power -1, better that is. So x to the power a. And hence we recall over here, that is let's say that it will become that is limit x tends to 0. Now you take out e power -1 common over here, and hence we say e power log of means base e. So 1 minus x to the base e upon x. Okay, and here that is minus what do you have to write? This is also +1, and here e power -1, that will be common. So that what we say here, that is -1, you can say over here. And hence, so we have used +1 as e power -1 is not there. So we have taken e power -1 common. So to manipulate this, we have written here +1. So now to just manipulate this idea, this should be in denominator to make the formula e power fx -1 upon fx. So that is, this is fx part. So what we say over here, log of 1 plus x to the base e, you can say over here, upon x, right, and +1. So e power fx -1 upon fx, that is same. And here you divide and multiply with this log of 1 plus x to the base e upon x. And here what we say, +1, that is +1. And finally, that is, you have to divide this left part, that is x to the power a also. Now you see, this part is entire. This result will be, if you see this part, so this part will be later on we can go for 1 also. But here the question is given here. You have to find the value of a, so that this limit, the real value of a for which the right limit is equal to a non-zero real number, means limit exists. You have to show here that limit will exist here. So let's see. So L equal to, that is e power minus 1, and here what we recall, that is this will become 1, and we have to bother about this limit. So that it will be log 1 plus x divided by x. If you open this, then you will find here, that is minus x, and here because 1 retaliated, and here that is 1 plus, that is, it means here like this way, minus x. So, and okay, so what we recall here, you consider this x as x over here, so minus x plus x square by 2, and here that is all of them will be minus here. So you know, that is log 1 plus x, and like this way. So what we see here, x cube by 3, x cube by 3, and so on, and so on, dot dot dot, and that is here, this is the in bracket here what we call, and that is plus 1. So what we say here, that it will be plus x, and here that is the another x will be considered with the a. So x to the power, what we recall over here, that is a plus 1, that denominator x, and now this x and x left over here, this is also negative sign. So that is because all the terms will be negative over here. If you see, this term is also negative, x minus x square minus x cube, all terms will be negative. So you see here, that is x and x left, and finally what we conclude over here, that is x to the power a plus 1 finally. Okay, so that what we call to limit to exist. So the value of L will be here e power minus 1, and here the result will be left with minus 1 by 2 as over here. So means the limit value will be L is equal to that the answer will be minus 1 by 2e. But here in this question, you haven't to find limit. So limit to be exist here, you have to find the value of a. So that in this situation, what you have to do, you have to make this powers of x, means exponents of x, so that they will be same. So that what we say here, a plus 1 should be equal to 2, and hence this a equal to 1. Okay, so this is the result here, that is called a equal to 1, and that's your answer. Finally, the answer is a equal to 1. 1 is your final answer, the end of the paper. Okay, fine, thank you.